That's a polar equation for it. Agreed, everybody? And that's where I'd leave it. Yeah, you could factor an R out if you wanted to, but what else is there to do? Ed?
If you're gonna check it on your graph, or if you wanna simplify it to the point where R equals something.
Yeah, but R equals something's pretty hard in this case.
Well, I get R sine theta. R is equal to 6 sine theta, and the graph's perfectly on the graph.
R is equal to the square root of 6 sine, 6 R. No, you got, this is R times R minus 6 sine theta equals 0. See?
You can divide both sides by R.
Yeah, but that changes the equation. That throws away a root.
You know, but on the graph, it doesn't make any difference. If I plug in R equals 6 sine theta, I get a circle of radius 3 centered right at 0, 3.
Okay. So what Dr. Thomas is telling you is if you graph one of those roots, if the R, all you're doing is throwing away 1 point. Is that right? R equals 0? So if you graph if you graph R equal 6 sine theta, you would get the same graph as you did that. Follow? So he's telling you, he showed you how to graph parametric equations, and a polar equation is a parametric equation, right? So you graph the parametric equation, and you graph the XY equation, and you look at the graphs, and if they're the same, you converted them, and you know that it's right before you turn your test paper in. Was that not your point?
Well, I mean, when you do a polar, you have to hit a separate thing called the polar on the load screen, and it's going to give you R equals
and then do it just like you would Y equal.
Right.
Yeah.
And the neat thing, remember, in regular you can't sketch a vertical line, but when you get to this thing, if you have something like R over sine theta, like R equals 6 over 6 cosecant theta, you'll get a straight line, vertical line, but you can't get it on the other screen.
So all we're saying is that if you graph both of them and you get the same graph, then you know you converted it correctly. Okay? And I'm going to put a conversion problem on the test, but I'm going to hate myself for doing it. That's college algebra or trigonometry, not Cal 3, but since we did it, I'm going to give you a chance to pad your grade a little bit. Okay? That was example 5. How about example 6? This is page 647. And I'm going to do B6D, and I'll probably do 6C. Convert to Cartesian coordinates. Okay? I know, so in order to convert, I know that R squared is equal to X squared plus Y squared. Didn't we agree on that a minute ago? Is equal to 4 times R cosine theta. What's R cosine theta equal to? Indeed it is. Or x squared plus y squared minus 4x equals 0, and that's the same equation in Cartesian coordinates. And if you wanted to, you could complete the square, right? And find that that is x, what? Half of the middle term, half of the coefficient of the middle term, and square it, so that it'd be y minus 2 squared. And then you would add a 4 on the other side, so that's a circle at center is 0, 4 with radius 4. You get the idea? All they told us to do was write it in terms of x and y. Okay? Let's do 6C. Not so simple, huh? Any suggestions?
Square everything?
Yeah, but
Multiply both sides by r.
if I squared everything, I'd have r squared, I'd have 16 up there, but I would have a middle term down here of sine theta, cosine theta, right? That's not a bad thought. What I think I'd do is I'm going to just start slugging it out. And that is, I think that the square root of x squared plus y squared is equal to 4 over 2 times x over r minus y over r. Is that right? Is that right? Yes or no? I took the square root of x squared plus y squared off because I can make it look better, can't I? What would I do? What if I multiplied both sides by r? Can I do that? Doesn't that mean that r squared is equal to 4 over 2x minus y? And now I know that so x squared plus y squared is equal 4 over 2x minus y. Is that right? Hardly pretty, but the directions said convert it to Cartesian coordinates. Did we do what they told us? And I told you a long time ago that in Cal 3, 4, and DE, beauty is in the eye of the beholder. And that is, your answer looks good when you can use it to solve whatever problem you're working on, huh? So what I'm telling you is, it doesn't trouble me a bit to leave it just like that. If you didn't want to, wouldn't you just have wouldn't you just multiply by the denominator on the right? But you'd have a hard time convincing me that that's any better than what we have up there. Isn't neither one of them sort of ugly? Agreed? So quit. Kenny Rogers. Doesn't know when to fold it.
No, you're gonna sketch R equals theta. You have a sketch R equals theta.
R equal theta.
Yeah. Get something interesting that pops up.
Any R and any theta? What is that? The whole plane, isn't it?
It's called the spiral of Archimedes.
No. Okay. Let me show you something. X and Y axis still the same as they've always been, right? In order to have symmetry with the X axis, if I know that this point is on the curve, doesn't that mean that this point has to be on the curve also? Isn't that what symmetry means? Mirror image. I take this graph and I fold it at the x-axis, and all I see is one dot. Isn't that what symmetry means? So, the first thing I'd tell you is the test for symmetry, one, is if the point R and theta is on a graph and, number one, R minus theta, I can make a better minus theta, R minus theta is also on the graph, then symmetry with respect to the x-axis. If this is the point R theta, and this point right here, the point R minus theta, if those 2 points are on the graph, doesn't that mean that the graph is a mirror image along the x-axis? And that's all I'm saying. Okay? Now, the origin, symmetry with respect to the origin says that if r theta is on the graph, in order to have symmetry with respect to the origin, what has to happen? Doesn't this point minus r theta, doesn't that have to be on the graph? Symmetry with respect to the x-axis. Everybody agree? I mean, with respect to the origin. So I would say number 2 is, if r theta is on the graph and minus r theta is also on the graph, then symmetry with respect to the y-axis. Not the y-axis, I'm sorry. With respect to the origin. Do you agree? Everybody? Now let's do the y-axis. If r theta is on the graph, then this point would also have to be on the graph. Is that right? What are the coordinates of that point? If the first point up there is r and theta, what are the coordinates of that?
Negative r, negative theta.
Very good. That's exactly right. Negative r, negative theta. Isn't this angle negative theta? And negative r says go backwards. Doesn't that get you exactly to that point up there? So 3 is negative r, negative theta is also on the graph. Then symmetry with respect to the y-axis. Now let's be clear. Let's be clear. Those are the 3 methods of finding symmetry. There is a 4th method, Dr. Thomas. What is it?
Inspection.
What does inspection mean, Ed?
You look at it, it's kind of obvious.
It means graph it on your calculator and look at it and see if it's a mirror image.
There's a lot like that in the homework. Then you know how to do use that grapher to get through a lot of the homework.
On the test, the 4th method is the way you check your answer. If you tell me it has symmetry because I graphed it on my calculator and saw that it was the same thing, you get no points. I want you to, if I say discuss the symmetry, that means do one of those. Understood? The calculator is a tool. It is not the means. We're gonna do analytic geometry to determine it. It doesn't matter to me if you want to check your answer using technology that's available, but I am not going to make you a technology cripple. You're going to have to show me how to do it. okay? So let's do a problem. And that is, no, let's don't do a problem. Time to quit. We'll graph one then on Friday. The first thing we'll do is determine symmetry. And then what we'll do is, instead of graphing it in all 4 quadrants, we will graph it in whatever quadrants we have to, and then we'll use symmetry to do the rest. Okay? All right, see you Friday. On the bottom of the last page of that is the schedule for tests in the class and when homework is due. Seth, come up here.
Yes, sir.